Hi everyone, and welcome to this tutorial. In this tutorial I will show you how to configure the SOCKS proxy and how to do that on an emulated network using the IMUNES network emulation software. So the tutorial is both helpful to understand what's the SOCKS proxy, what's the circuit level gateway, and see how to take like a scenario and implement it using the SOCKS configurations. And also it will help you demonstrate this and similar network and security concepts on the IMUNES network emulation software. And in this tutorial I will also be demonstrating some advanced features of IMUNES, such as adding startup scripts, how to create like permanent configuration files for individual emulated hosts, and also how can we install additional packages, because by default the SOCKS server and client are not part of the standard IMUNES Docker images. So we will see how we can install them, and then we will also see how to run graphical like GUI applications on the IMUNES computer. So we'll be able to run like Firefox browser on PCs and test the SOCKS configuration settings. So SOCKS is a circuit level gateway. It's a type of like firewall that operates at the transport layer. It can be part of an application gateway, but we will not be concerned about the application gateway function, so we will just focus on the SOCKS server and client. So in circuit level gateway we don't have a direct end-to-end connection. We create two separate connections. So if I want to connect, for example, using a SOCKS, suppose this is a SOCKS server, I want to connect to from PC1 to this web server. I cannot establish direct connection, so direct connection is not allowed. So I will need to create two separate connections. So connection from a PC to SOCKS server, and then another connection from the SOCKS server to the web server. So in this scenario we want to have direct connection only between computers on LAN 0. So LAN 0 PCs can interact directly. Maybe this is just a standard desktop LAN. Then we have LAN 1. This LAN actually can access the internet, so maybe let's call this internet LAN. This one maybe we can call it intranet, and then maybe this can be like servers, maybe LAN, so LAN 2, and then LAN 3 can be like a private. So this is the pink LAN, it's a private LAN. This is the most protected. Now this is the gateway router that connects all LANs to the internet. So through the one connection, it doesn't have to be like a just a one hop connection. We can have any number of routers between router 1 and router 2, but this is just to demonstrate how we can connect from LAN 0 to any external network. So in this scenario, first we want to allow HTTP only connections from LAN 0 to the internet, and then we want to also allow connections to LAN 3 computers, for example host 1, but only through a connection coming from SOCKS 2, which will be chained to SOCKS 3 server. So if we want to establish a connection from any client on LAN 0, we want to connect through SOCKS 2 server, and then the connection will be chained to a SOCKS 3 server, and then it will be connected from there. So we don't have a direct TCP connection in any of these cases. If you look, let me just hide the annotations. So if you look, you can see that this is the only router in the network. This SOCKS server has a dual homed connection, so it's connected to LAN 1 and LAN 0, but normally a standard host does not route any traffic. So LAN 0, LAN 2, LAN 3 devices are isolated from the internet. These in security terms we can call this a bastion host. So a dual homed bastion host, it's configured by default. It does not route any traffic from one LAN to another. So we will set up a SOCKS server on these three servers: SOCKS 1, SOCKS 2, SOCKS 3. They will only allow connections as defined by our policy, and then you can connect only to the hosts or IP addresses specified in these policies. So let me now let's show the annotations again. Now let me run IMUNES. Now notice that there are some preliminaries required for this experiment. First, I need to install some packages on the IMUNES vroot Docker image. So the standard IMUNES Docker image does not contain packages such as the SOCKS server. So I will need to install that, and then here I will also want to run some graphical applications. So I need to install the socket, and also I need to run Firefox. So I will install. Okay, so I need to install socket to allow running GUI apps, and this needs to be installed both in IMUNES vroot image, and also on the host, the computer that I'm running IMUNES on. And then I need to install Firefox on IMUNES vroot, and yeah, this should be enough for us to run this experiment. So going to the shell, now I have already installed the required packages, but I'll show you the commands that I need to use to install them again. So now of course I need to use run them as super user. So sudo apt get underscore immune. So when you install immunes, you get this this binary in your path, so you can run it. So I install, just if you are familiar with Debian and Ubuntu, you can just use this command, and then it will be, the rest will be exactly as if you have used apt get. So install socket Firefox, sorry, yeah, I need to install Firefox because this is based on Debian, so it will be Firefox ESR. So both are already in the newest version, so I have previously installed them. And then I need to install and then server. These are the SOX implementation, the client, SOX client, and then the SOX server. Yeah, then client and then server. So they have already been installed, so now we are ready to go. So these are the preliminaries we need to do before we can use IMUNES to test the SOX implementation. So now I can run IMUNES. Now as I mentioned in a previous video, that I can run IMUNES as a normal user, but if I want to run experiment, then I need to run it as super user. So sudo IMUNES. Now I might need to use the shell again, so I just do Control Z and then background the IMUNES process. So now I can run command 0 if I need to. And on the IMUNES menu, on the IMUNES topology, I'll just create a topology similar to this one. So let me start by adding the router. So this is the router that connects the entire local network to the WAN. So I have and then a router that will be used for the destination outside server. So if I make any mistake, I can just press Ctrl Z. Then I will add some PCs, so PC1, PC2, PC3. I will add some hosts to do the act as a SOCKS server. So host 1, I will rename them later. So this is the external host. This is the LAN 3 host. These two are the SOCKS server, and this one is a SOCKS server as well. I can add switches. Now the switches are not really necessary in this experiment, but just to make it more realistic, because usually you don't connect a router to PCs directly, because the router usually has limited number of ports. So let's see if this, I think it's enough. I'll save this. Let's call it SOCKS demo. I will now add links. Now be careful in IMUNES. The subnets are automatically numbered, so auto assign IP addresses. So just to make the IP addresses map nicely to the LAN numbers, I will start with the LAN 0. Now it does not affect the performance in any way, but just to make the like a nicer mapping between the LAN numbers and the IP addresses, the subnet addresses. So we'll start by LAN 0. So connect. So switch 1 to router 1. I can hide the IPv6 addresses to reduce the clutter. Now PC1, PC2, PC3, and then host 1, host 2. Now notice that the hosts are numbered starting from number 10. The PCs are numbered starting from 20, and usually the router gets IP addresses starting from 1. So this is LAN 0. So LAN 1 is just the LAN. Yeah, this is. Yes, actually this link is not. I don't need any direct connection from LAN 0 to the internet. So as you can see, the connection has to go through the SOCKS server. So I call this SOCKS 1. SOCKS 2, SOCKS 3, let's call this host 1. This is an internal and private host. Let's call this web 1, just to indicate that is a web server that's running outside. Okay, so now the IP, this is LAN 1. This is the IP of the router side, and this is the IP of the server, the SOC server side. So just connect switches to hosts. So now I have LAN 2. You can see the subnet address is 2. LAN 3 subnet address has 3. Now this is not really a LAN, so usually the IP addresses will not be in the same range as the LAN. Usually we'll use public IP addresses. I'm not going to change this one because we will not access any device in this on this subnet, but I'll just, maybe this one I just rename, just use a different range. So for example, I can configure this router interfaces. So this is the interface Ethernet 1. I can just change. Let's use some IP that appears to be a public IP. So 1.2.3.1. And then this one, I just make it 1.2.3.10. Now the IMUs will generate routes directly for routers, but it will not generate like if I want to specify the, you see, the, because I changed the interface IP address, I need to change the default gateway IP address, because otherwise this host will not be able to send any packets to outside, because it has an invalid default gateway. So this static route 0000/0 means this any address. So this is basically the default gateway specification. So I need to change this to 1.2.3.1, so that by default the default gateway for web 1 is router 2. Now if I haven't changed the IP addresses, I wouldn't have to change this, because it would have been already set up. Okay, so now we need to configure the SOC server. Now we can do that after we run the experiment, but it's not very practical, especially for large networks, to have to go every time we run the experiment and change the configuration files. So I will show you how we can make like persistent configurations and startup scripts. So first let's look at the configuration files. So now this is the SOX configuration file. Then we will name it just danted.conf. I just named it here using the server names just for clarity. So I just followed the same order as in the documentation of the Dan server. So the log output, so we can see what's happening with the server. Now in the internal port and IP address. So if we look here, this is the internal IP address 10.0.0.10, and the port number, this is the standard port number for the Dant, the SOX server. Now SOX method means the authentication method. I will not use any authentication, so I will just base my authentication on the IP address. So we'll just control access based on the IP. I will not make any authentication requirements. Then we have to add a section to just allow the client to connect. So which clients, which IP addresses can connect to this SOX server. So we add from 10.0.0, so the subnet, the LAN 0 subnet, to any address. So they can connect to the SOX server, any of the server addresses. I can specify which server address if I have multiple addresses, or I can just put 0000/0 to allow access to the SOX server from any of its addresses. And then I add the log entry for the connection, disconnection, and errors, so to this log file. Now this is the part that implements the policy. So now I will allow access from LAN 0 subnet, so 10.0.0.0/24, to any address on port 80. So I just allow HTTP traffic from these clients, from the LAN 0 clients, to any address on port 80. And also I will log connect, disconnect, error. Now on the client side, on the PC side, I need to add this configuration. So here I add route sections. So based on the source and destination and other parameters, like transport layer parameters, I can tell the Dant client, the SOX client, how to route this traffic. So from this should be 0. Sorry, this should be 0, 0. So any direct connection from PCs does not have to go through the SOX server, so they can communicate with each other directly. Now if I want to access LAN 3, maybe it's now if I want to access LAN 3, then I need to connect to the SOX server 10.0.0.11, so SOX 2. So connections to LAN 3, so this is the destination. I will use the SOX server 10.0.0.11 on port 1080, and the proxy protocol. Now suppose if I have an old version, Now the version 5 is the current version, but if I can put multiple versions just in case the SOC server has only old version. So there are three clauses: one for direct access, one for LAN 3 access, and then one for internet access. So route from any device. I can specify the internal IP address, or I can just leave it any address. It doesn't matter. So anything that has not already been specified in previous clauses as a destination will be covered by this clause. So this will go via the SOC server 1. So SOC 1 10.0.0.10 on port 1080. Okay, so basically this what it says, that anything else will go through SOC 1, any other connection other than the previous two. So SOC 2 is an example configuration where we need to actually forward connection request to another. So this is called chaining. So I will chain the connection request through another SOC server. So okay, this is a standard. I specify the internal and external. So I can specify the external using IP address as well. So I can put 10.0.2.10, or I can use the Ethernet or the interface name. So I use both just to show you that both can be used. It's better to be consistent. So I could have just used Ethernet 0, Ethernet 1, or I could have just used the IP for both. But I use combination just to show you that both can be used. So now this is standard. Usually you will need to add this client path just to enable clients to access the SOC server. So you specify the IP range, and again the port, you notice that here I did not put a port number. I just added it here just to show you that you can limit the source port numbers. Okay, if you don't, now this is the basically the entire range. So I didn't need to add it, but I just added it here just to show you that you can actually limit the port numbers either for the source or the destination. So now for chaining, I need to add two clauses: one SOC's path and then one route. So SOC's path, so just to allow this connection from LAN 0 to LAN 3. Again, the port specification is not really necessary. And then another clause just to chain this connection request. So they will be passed, and then they will be routed to SOC server 3. So from 10.0.0.0/24 to 10.0.30/24 via 10.0.2.10 port 1080. Okay, and now finally for SOC 3, again the internal external already explained. Now here notice that the client, I did not put the LAN 0 IP, because the connection, when it comes from SOX2 server, it will not have the IP address of LAN 0. It will have an IP address of LAN 2, because the SOX server is circuit level gateway. It establishes two connections, so it maintains two separate connections. The actual connection coming to SOX3, it will have a source address 10.02 10.02 range. So allow the client to connect, and then allow SOX request. So just like previous, just like here, except that I used the IP address of the LAN 2 interface of SOX2 server. Okay, now how do I get these configuration files in IMUNES? So if you just right click, you see that I can have a custom startup config. So I enable this and then click on the editor. So I create a new configuration. Maybe let's call it SOX1. Now notice that if I just start adding commands here directly, I will lose the standard configuration. The standard configuration commands are necessary to set up the static routes, set up the IP addresses. So first I just fill the defaults. So just fill the default. So this default generated from the topology as I have created in IMUNES. And then I can add any commands. Now this is also important if I decide to make any changes later, like for example I change the IP addresses, then I need to fill the defaults again before I add my own script. Now and notice that here it does not allow me directly to add configuration files. I need a configuration file for the DAN server. It will be under etc/dant.conf. So how can I add content to this file? I can use the cat command. So cat, and then if from multiple lines I just put a delimiter, so EOF, and then to the output. So I append to this file. Usually there is a standard configuration file, but it doesn't have any it does not have the configuration that we need. So I'll just append to this file, and then anything before the EOF will be appended to this file. Okay, so I can copy this configuration lines to the DANT server configuration. Okay, now also I need to start the DANT server. There's no like a menu option in IMUNES to start a custom server. So I need to add a line. I need to run DANT as a service. So service start. Okay, so this command will add these lines to the configuration file, and then this command will start the service. Now I need to do the same for SOX2. So enable editor, create, and then let's call it sucks2, and then fill default, and then again cat eof etc slash dent conf. And just copy these lines, eof, and then service dent start, and then sucks3 I do the same thing. Fill default, then I copy, so cat eof etc dent conf, eof, and then service dent start. Now notice that this is the selected custom config. Now finally I need to configure the clients, so this is the client part. So I'll just copy, sucks PC, fill defaults, cat. Now notice here I do not need to start any service because the client will just run on demand. And notice also that the file name is dent without d.conf. Now I copy this because I'll do the same for PC2 and PC3. So Control C. So I do the same. So PC, fill defaults, apply and close. PC3 I do the same. So sucks PC, create, fill defaults, apply and close. Okay, so I think now we are ready to start the experiment. Let's resize this window to fit in our screen. So save, execute. Okay, there seems to be an error. Node sucks3. Maybe we made some mistake in the configuration. So let's Okay, I think, yeah, I did not assign the addresses correctly. So yeah, because I made the configuration based, so SOX3 internal, yeah, so yeah, the internal address is 210. Yeah, here the internal address is 211, so it's inconsistent. Yeah, because yeah, you see here the order of creating the links can affect the numbering. So now instead of having to change the configuration files, I'll just delete the link and just create them again in the same order. So right click, delete, and then I just add the link. This time I'll do this one first so that it gets the 10 IP address, and then I create this one to get the 11 IP address. So, and this double check SOX2. Yeah. So save. Let's start the experiment again. Oh, it's still an error. Probably it is the, let's see what's the error. So cat etc, sorry, outlog cannot assign. Custom count, so internal 10 0 to 10. Okay, yeah, remember I just mentioned that if I make any changes to the IP, then I need to fill, yeah, I need to fill the, yeah, I need to fill the configuration, fill defaults again. So yeah, just overwrite and then just copy. Yeah, so this, yeah, yeah, I don't like to have mistakes, but it's good to show because you might face the same the same errors, so it's good to know how to deal with them. So cat eof etc and counts here, eof, and then service, then so then start. So save. Okay, let's hope we don't get any errors this time. Okay, so now we have our configuration, so let's double check. So maybe, yeah, so they have the lines correctly. Now I'm not going to check all of them. Let's try and see if everything works as expected. Now here I'm going to start a web server. So let's use a standard, just a dummy server first. So nc-l-p80. Then let's see what is in, how the log file is updated. So tail-f var log sox1.log. Now if I try now nc 1 2 3 10 80, I cannot connect directly because there is no routes. You see here I only have a route to default gateway 10.0.0.1, which is the IP of, actually no device has this IP address, so there is no route to external hosts, so I cannot connect directly. I'm forced to use SOCKS. So now there are two ways, or two main ways to use the SOCKS client. Either I can use the socksify command, or I can use the SOCKS library as an environment variable, and then I can use a command without the socksify shell. So let's use the socksify command. So socksify and then nc 1 2 3 10 80. Okay, so you can see now I was able to connect, and here in the log I can see that the connection, okay, passed. So TCP accept and then TCP connect. So now a connection has happened. So now I can test the connection. So hi, so here so hello, so I can send packets back and forth between PC1 and Web1. Okay, now let's try a more useful example. So I'll just close. So connection closed. So now instead of just using a dummy client, let me run a web server, a real web server. So maybe the built-in Python. So Python 3 -m http.server on port 80. So now I have a Python server running. Now I want to run a Firefox browser, so a graphical client. Let's also monitor this link. So on Wireshark on Ethernet 0, just to see where the packets are coming from, the source IP address. We can just filter TCP. Now here I cannot run graphical applications, so I need to use the now in IMUNES you can right click and then run web browser from here, but I tried this before and it caused IMUNES to crash. So there is an alternative way to do that from the terminal. I can just use the command start xcmd, and then I just put the name of the device, so name of PC1, and then Firefox. Okay, now if I try to do that, it tells me that I must be a root to run this, so I need to run it as a super user. So sudo. Now notice that if I run the Firefox directly, it will not work until I configure Firefox to use SOX. So you can ignore this error, it still works. Now if I do 1, 2, 3, 10, it will not work because I don't have route, so I need to configure. So you just press Alt and then preferences, network settings, just use a proxy, SOX proxy, so SOX host 10.0.0.10 and then port 1080, and then use SOX 5. Now I can connect to that, and then here let's also monitor the Wireshark window. So 3.10. So see, now I was able to connect after I configured the SOX proxy. And here if you look, source IP address is 10.0.1.10. okay, it's not the IP address of the client, it's not 10.0.0.20. so the SOX server actually the SOX server actually accepts a connection from the PC, but then it creates another connection to the web server. Okay. Now obviously it's not a good idea in a real production server to run a server as a root and then expose all file system to the outside, but this is just a virtual machine, so we are just testing in a safe environment. You can probably do a more useful scenario. This is just a proof of concept. Okay, so now let's test the connection to the private, the LAN 3. So now I will let me terminate these servers. Close. Now on host 1 I'll just run a dummy server, so nc-l-p, just use any port number, so for example 8000. Then I just open a window here for SOX 2 and SOX 3, just to show what's added to the log files, and then maybe I can just open a PC3 window. just make sure the content PTCs. Yeah. So tail minus f var log sox2, and then tail minus f var log sox3. So now again I can try without the sox. So nc, here the IP address is 10.03.11. Ten 0311 8000. Okay, so there is no route, there's no way to connect directly, so I'll just use a Soxify. Okay, I think the same error happened. Yeah, because of the change in the interface name. So I'll just terminate the experiment and then just correct this configuration. See the address here, Ethernet 1 should be 11, Ethernet 0 should be 10. So I made a mistake, but I'll just fill the defaults and then just copy again sox2 configuration. Service start, apply and close, save, and then let's execute the experiment again. So host 1 nc minus l minus p 8000, sox3 tail minus f var log sox2 tail minus f var log and then PC3 so nc 10.03.11 8000. Now it will not work directly, so now I use the Soxify command. See, I finally managed to get it working. So now the connection went, see, from the the client 10.00.22, and the support number, and then it went to 211, from 211 to 210. Port 1080 here, from 211 to 1080, and then it will be forwarded to 10.03.10 to 10.03.11 port 8000. So now I have a connection. Now two SOX servers are involved, so we actually have three connections, one from PC3 to SOX2, one from SOX2 to SOX3, and then one from SOX3 to host 1. So now I can test this. So hi, and then here hello. Okay, so you see here the idea how we can use the SOX server and the client configurations, how we can add startup scripts configurations and startup commands to the IMUNES hosts, and then how we can also run graphical applications such as Firefox on IMUNES hosts. So thanks for watching. Thanks very much, and see you again in a coming video.